So let me go back to the screen before this. If this is the exponential function, this other graph that you saw, the blue line, represents a logarithmic function. And what exactly is a log? Let me put it to you this way. If a is equal to b to the power of c, if that's your function, that's your exponential function, then the way, and by the way, let's make sure that everybody is hearing me fine. Can you all hear me, please? Let me just check in with the room on this. Okay, great. If a is equal to b to the power of c, so we just had, for instance, let me just grab my stylus here. What we were just dealing with was y is equal to 2 to the power of x. That's what we just had a few minutes ago. Well, if that's the exponential function, then the log function would be log base, what's called the base 2, right, of y is equal to x. 2 to the power of x is equal to y. Sorry about that, folks. Okay, so that's really what the definition is. These two things are inverses of each other. If y is equal to 2 to the power of x, then the log base 2 using this base of y is equal to x. So, for instance, same thing is being said here. If 4 to the power of 2 is equal to 16, which it is, right? That's just a statement of fact, right? That 4 squared is 16. Then the log base 4 of 16 is equal to 2. Right? And really what a log is an exponent. So this thing here, this 2, right? That's really what becomes your log. So if you raise 4, if you use that base and raise that to the power of 2, then that becomes your log, which is what this is here, right? And it's the same thing for the second line, right? 3 to the minus 3 is equal to 1 over 27. That's just a fact, right? I'm stating a fact. Then if I take the base 3 log of 1 over 27, then that's equal to minus 3, right? Remember, I'm going to say this again. Every log that you have is an exponent. Anytime you have any doubt about whether the thing that you're looking at is a log, just ask yourself, could this have been considered to be an exponent? And that would qualify, therefore, as a log, right? Look back at the first one I wrote. That x became the log. The log base 2 of y was x. This 2 became the log. The log of the log base 4 of 16 is 2. This minus 3 became the log. The log base 3 of 1 over 27 is minus 3, and so on and so forth. So whatever was the log, right? Whatever was the exponent becomes a log. Here's another 2. 10 to the power of 2 is equal to 100. Another statement of fact. That's just a fact. Now, notice that I put log of 100 equals 2 and I didn't put a base here. And that is because it is always assumed that if you don't have an explicit base stated, that is implied to be a base 10. So even though I don't have 10 here explicitly, it does mean I'm taking a base 10 log. And just so you know, on your calculator, and you can take your calculators out now, you'll see a log key on there. That log key assumes that you're dealing with a base 10, right? We're going to talk later on about how you can find any other base. But right now, the key on your calculator is a base 10 log key. So if you go ahead and press log of 100 on your calculator, you're supposed to get 2. All right? So let me ask the next question. What about the log of 10,000? Right? Again, I'm not going to put a base, right? I'm just going to say the log of 10,000. What should that be equal to? Well, ask yourself, what do I raise 10,000? What do I raise 10 to get 10,000? The answer, of course, yeah, you saw what he has there, is 4. So the log of 10,000 is actually 4 because 10 to the power of 4 is equal to 10,000. Right? So that's simply it. If you're using a base of 10, what number, because our log is an exponent, what number do I raise that 10 to give me that 10,000? And the answer, as I said before, thank you, Donna and Davina, Chrisania, Brannan, Roma, and so many other people, Leanne, gave me that correctly. So there you go. How about this? There is something else that we haven't yet talked about much. What about if it's a different base? There's another key in your calculator, which you should see, that has an ln beside it, right? Can you find that on your calculator, please? Everybody look on your calculator. See, it's probably usually beside the log key. I can bring up my virtual calculator for you in a minute, but you should be able to find another key on your calculator, right? Which says ln, and it's usually right beside the log key. Perfect. So what base is that? Well, that base is the base e. You're probably wondering, well, what is e? Right? The other one was base 10. Well, we know what 10 is. That's a pretty, that's a number that we've used all along. What is base e? Well, base e is this number, which is just like pi. It's an actual number, but it's irrational. You cannot express e as a fraction. 2.71828, and it goes on from there. Where did it come from? So you can't find it. I'm pretty sure it's there somewhere, Leanne. Look for ln. Rather than log, it should be ln. So usually it's two lowercase letters. I'm sure it's there. It's because I signed the calculator, it's going to be there somewhere. That ln key has a different base than the log key. The log key is a base 10. The ln key is a base e. And what is e? It's a constant. It's going to come up in calculus, those of you are going on to calculus. But let's just sufficient to say that it's just like pi, which is an irrational number. It's a constant that has a special place in math. And we use it for natural logs. By the way, this is called natural logs. That's what they call ln. So let me ask this other question. What if I ask for the ln of e? Can anybody tell me what that might be? Right? What should the ln, if I ask for the natural log of e, what do you think that would be? I'm going to give you a clue. What do you think is the log base 10 of 10? What do you think that is? What's the base 10 log of 10? Anybody? Anybody think they know what the base 10 log of 10 is? Quinn says 1. You're absolutely right. Because remember, it is what I'm going to raise 10 to get 10. So what is the base e log? Remember that ln means it's a base e. So what's the base e log of e then? It would be the same thing that Quinn just got. It would be 1, just so you know. Right? If the base matches the thing that you're trying to find the log of, answer is always going to be 1. All right? Okay, let's keep this going. Let's rewrite, right? Remember, this is 16 equals 2 to the power of 4. Again, that's a statement of fact, right? If I take 2 to the power of 4, 2 times 2 times 2, 1, 2, 3, 4. Yeah, I think I did that 4 times. That would give me 16. So the question is, what is this in log form? So in log form, that should be the log base 2 of 16, which is equal to 4, right? So the base 2 log of 16 is 4, right? And that is because if I took 2 and raise that to the power of 4, I'm going to get 16. That's why that is the logarithmic form of that exponential expression. So this is the exponential form. This is the logarithmic form. Okay. All right. Let's get to the next one. Now, this one is just a simple variable. M equals n to the power of 3. Now, remember, what base should we be dealing with? Well, base n. But that's the base of this, this power right here. So this should be the log base n of m is equal to 3. Okay, again, just remember the exponent is what you're going to set your log equal to every time. What was the exponent? The exponent here was 3. So the log base n of m is equal to 3. All right. Okay, how about the next one? 3 to the minus 2 is equal to 1 over 9. Let's put that in exponential form. Again, that's a statement of fact that if I raise 3 to the minus 2, it's going to give me 1 over 9. That's just a fact, right? So the log, what base should I be taking this time? Let me go to the room now. Log, okay, so it's a log base 3, good. We're taking log base 3 of, yes, 1 over 9, perfect. And that's actually equal to minus 2. Okay, well done, well done. Thank you, Christina, by the way. Thanks, Roma, thanks, Donna. So those are sort of the ways in which we can interpret an exponential form in terms of logarithms, right? We can take any exponential form and make it look like it's a log, all right? Because they're equivalent statements. These are just reciprocal, sorry, inverses of each other, but they're saying exactly the same thing. Let's go the other way. If I gave you if I gave you log form, and again, this is a statement of fact that the log base 4 of 64 is 3, that's a fact. How could I write this in exponential form? What to the power of what is equal to what? That's what I'm asking. So 64 is equal to 4 to the power of 3, absolutely. Or I put it the other way around. 4 to the power of 3 is equal to 64. That again is just a statement of fact. Thank you, Roma. How about the next one though? Y equals log x. Again, remember, I didn't state the base here. So we make an assumption when we don't state the base. What would that be in this case? In exponential form. What do you think, folks? But, it's time for me to grab my wheel here. I haven't had that wheel come into the picture in a couple of days. So let's see what the wheel says. I'm asking you to express y equals log x in exponential form. And it looks like we're going to go to Daniel. Daniel, can you help me out, please? Nobody else put anything in the chat right now. Y equals log of x. Y equals log of x. Daniel, are you there? Good, perfect. Can you help me out, please? Remember what the base is, right? So in your mind, I want you to think this is the same thing as saying y equals a base 10 log of x. So give me that in exponential form now, please. Tell you what we're going to do. Let's go back and look at the one we had before. All right. Over here, we had a base of 4 of 64, which was equal to 3. So what we did is, right, if you follow along, look back at the one we had before, we took that base, raised it to the exponent of 3 on the other side, and set that equal to 64. So follow that same logic, but let me help you a little bit. I'm going to restate this by saying that y is equal to the log base 10 of x, right? So think about it that way, or let me put it so that it looks sort of like the one above it. So log base 10 of x is equal to y. Right? So let's try that again. Look at the one before it. Right? So log base 4 of 64 was equal to 3. So 4 to the power 3 is equal to 64. Just look at just put everything in the same place. So log base 10 of x is equal to y. Just follow the same strategy that I have on the previous line. Okay, look at where those things were and just substitute in for the things that I have in this line. All right, so this is what I'm pointing to right here. So try again, please. Because I'm not asking you to solve for y. I'm asking you to put it in exponential form. So something raised to the power of something else is equal to something. Look at the one before. If you need more help, you let me know. So 10 to the power of y equals x. Okay. All right, so this number raised to that number is equal to this number is absolutely correct. All right, Daniel, makes sense to you now? Does that whole process make sense to you? I want to make sure that you followed what you just did because your answer is right. Yes, does that make sense? Okay, perfect. All right. Now we'd have to actually evaluate, right? And let's see how well we do with this. I am going to go to my wheel, right? Let me just warn you right now. I'm going to be asking you each to see if you can figure out what each of these things is without a calculator. And by the way, your calculator really only shows base 10 anyway, and these are not all base 10s. So let me take out Daniel for today. Think about the log base 3 of 81. That's what I'm asking you to do. Take the log base 3 of 81, and that question goes to Ella, by the way. So Ella, are you able to give us an answer for that? And if you're not, I can walk you through a process that might help you out. The log base 3 of 81. Ella, do you have an answer? Oh, by the way, Ella, are you there? Let me start with that. Is Ella with us? Perfect. Can you give me an answer for the log base 3 of 81? And I can walk you through a process if you need me to do that, but just let's see if you have an answer first. The log base 3 of 81. Don't know? Okay, so let's do this then. Let us set this equal to, I'm going to use black actually. Let's just set this equal to x. Okay? Because that's a good enough start, right? We're going to figure out what that x is. What's that thing on the other side? Now, remember what Daniel just did a few minutes ago? Put that in exponential form. Now, I can take you back to what Daniel just did a few minutes ago. When we had that the log base 10 of x was equal to y, or y is equal to the base 10 log of x, we took that and we made it 10 to the power of y is equal to the x. Did that make sense, first of all, Ella, before I go back to the page? And did that what Daniel did? Did that what Daniel did make? Okay, perfect. So what I want you to do now is to put this in exponential form. The log base 3 of 81 equals x. Hopefully you wrote down what we had on the previous page, and I'm asking you to follow through and rewrite this in exponential form. This is log form. Let's put it in exponential form now. 3 to the power of x plus 81 or equals 81? Which one is it? You meant equals. Okay, good. 3 to the power of x is equal to 81. Excellent. Good. So the question now is, good, Ella, what can I raise 3 to that gives me 81? Now you can use your calculator to play around with that for a while, but I'm sure that eventually you'll get what that is. What x value is going to, when I raise 3 to it, Roma, could you please not do that? And Don and everybody else. I'm just asking Ella right now. Ella, please ignore those answers, right? I don't know that they're right. I'd like to ask you what you think, Ella, right? What can I raise 3 to? That's going to give me 81. Like I said, you can use your calculator to sort of help you through that. Try different numbers until you hit the one that gives you 81. All right, Ella? So back over to you. Let's hear what you got. So Ella is saying 4. So that's what exactly what the x is. So to answer the original question, thank you, Ella, by the way. To answer the original question, which is the one in the box, the base 3 log of 81, right? Without using anything fancy, and there is a way that we're going to learn how to do this, which makes it much easier. But for now, let's just conceptualize it. The base 3 log of 81 is in fact 4, right? Set it equal to x first, put it in exponential form. That should help you out. Okay, thank you very much, Ella. Let me go over and take Ella out for today. And let's try to get the log base 2 of 1 over 8. Try to think about what that means. And this question is going to go to Chrisania. So Chrisania, do you have an answer first of all, Chrisania, before I actually help you through it? Oh, by the way, Chrisania, are you there? You're usually quite perfect. Yeah, usually quite involved. So that's good. Can you give me an answer for that before we sort of break it down? Do you know the answer for that? The log base 2 of 1 over 8? You think you'd be able to come up with an answer for that? We can break it down a little bit more, but what do you think? Log base 2 of 1 over 8. Okay, oh, so you are in fact going to break it down then. So let's say set it equal to x first of all, and then 2 to the power of x is equal to 1 over 8. I agree with that. And you're saying 2 to the minus 3. So what's x then? So what are you saying x is then, in other words? That x is equal to minus 3. Perfect. Because 2 to the minus 3 does give you 1 over 8. And that means that x is equal to minus 3. That's the exponent that you put on the 2 that gives you that 1 over 8. Well done, Chrisania. Okay? All right. Is there anybody who needs me to go over that again before I go any further? Does that answer make sense? That the base 2 log of 1 over 8 is in fact equal to minus 3. Okay. Yes, please. You want to? Okay, fine. So let's do this then. Let me bring this down some more. Let's bring this stuff down some more. Okay. So let's do this. Let's first of all, I'm going to erase this for now. Can we agree on the second statement on the, can we agree on this part right here? Does that step make sense? Let's be sure. Okay, fine. So here's another thing that we could do then, right? Not just for Donna, but for everybody else. Why don't I try to make this 8 have a base of 2? So 2 to the power of x is equal to 1 over, what can I raise 2 to? And that's really what we're trying to focus on here. What can I raise 2 to that gives me 8? Can you help me with that, Donna? What number can I raise 2 to that gives me 8? Can you think of what that number is? It's 3. Good. So 2 to the power of x is equal to 1 over 2 to the power of 3. Now remember one of the things that Mr. Richards talked about a while ago. If I have 1 over 2 to the power of 3, another way that I can say the same thing is to say 2 to the power of minus 3. Can we agree on that? That 1 over 2 to the power of 3 is the same thing as 2 to the power of minus 3. Because when you flip it over, the minus will change sign to a positive. So instead of saying 1 over 2 to the power of 3, I can say 2 to the minus 3. Well, if 2 to the power of x is equal to 2 to the minus 3, in fact, let me just bring this up right now because we're going to be solving exponential equations eventually anyway. I'm going to write the statement down here. 2 to the power of x is equal to 2 to the minus 3. Well, if the two bases of the two sides, this is an equation, this side is equal to this side, right? What's on the left is equal to what's on the right. But the bases are already the same. If this part here is already the same on the two sides, that means that the other part of the equation also has to be the same. So if 2 is the same 2 over here, then it must mean that the x, which is this part up here, must be equal to this part over here. That's another way to look at it. If the bases, if these two things, these two sides are equal to each other, right? This is the logic of math. If these two sides are equal to each other, and you're also saying that the bases are the same, then it means that those green boxes have to be the same as well. And that means that therefore x must be equal to minus 3. So we've just solved for x by going through all of those steps. Does that help even a little bit, Donna and Sindhuja and everybody else who was asking? I just want to be sure now. Okay, how about Sindhuja? Are you okay with that? Are you okay? Good, perfect. All right, so let's get on to the next one. Let's get on to the next one. Let me bring this down here. And we'll put these other guys away for now. And we'll just focus on this one. So the log of 0.01. Okay, so that was Chrysania. Let's remove Chrysania. I want you to think about that as I go to Quinn. Okay, Quinn, are you there? You're normally quite involved. Are you there, Quinn? Perfect. First of all, Quinn, what base am I dealing with here? If it's not stated, what base is assumed? It's a base 10. So I'm going to rewrite this as the log base 10 of 0.01. But by the way, do you have the answer right away, or do you, or let's go, you want us to go through the process, or do you think you have the answer right now? Do you think you know the answer right now, Quinn? Sure. Okay. All right. So I'm going to set it equal to x, as we normally do. All right. So tell me now, Quinn, I'll give you the 5 seconds, but can I rewrite this, just like we did in the previous example, can I rewrite this in exponential form? Is there a way to rewrite this in exponential form? Good. So the question is, how can I figure out this thing with a base of 10 so that maybe I could use the same strategy I used before? Well, is there a way to write 0.01 as a fraction? Let's see if we can do this. 0.01 as a fraction, because if we have it as a fraction, that might make it look a lot like the one we just did. Does anybody know? Well, not just anybody. Let's focus on Quinn here for a bit. Is there anybody? No, sorry. Can Quinn or yeah? Let's stick with Quinn. Can I write this as a fraction 0.01? Is there a fraction for that? Something over something else? Let me tell you what I was taught. If I have any decimal, and we'll use a 0.01. If I want to make it into a fraction, I put 1 for the decimal and 0 for everything else after it. So there are two numbers. So I put 0, 0. So that's equal to 1 over 100. So let me help you out by saying that. So 1 over 100 is the same thing as 0.01. Okay? So what I'm going to do now is I'm going to restate the left-hand side. I'm helping out Quinn with this as 1 over 100 is equal to 10 to the power of x. Okay, back with you now, Quinn. Quinn, do you accept that my 1 over 100 is the same thing as 0.01? Can we accept that? Sure, absolutely. Let me go to a brand new page for that. If I gave you any decimal, just this, I mean, I use 0.01. If I gave you 0.5754 and asked you to, or let's put an even bigger number, 543, and said express that as a fraction. The way I was taught this, and it works the same way it did when I learned it, is to put this over 1 for the decimal point and 0 for all the numbers after it. So because there are 3 numbers after it, I need 3 zeros. So the number on top is now 543 over 1,000. Right? So let's try another one. 0.0078. 1 for the decimal. 1, 2, 3, 4. So that would be 78 over 10,000. And then, of course, if you can reduce it down, you should reduce it down. Okay? So the one that we have, Quinn, is 0.01. So that would be 1 for the decimal and 2 zeros. So 1 over 100. Okay? So to come back to this, we're now saying that I'm going to bring this down. We're now saying that instead of calling it 0.01, we're calling it 1 over 100. Okay, now, can we express that as 10 to some number? That's the question. I'm back to Quinn now. Can we express that 100 as 10 to some? Is there a number I can raise 10 to that gives me 100? Can you think of any number that would work for that, Quinn? 10 raised to a particular number gives me 100. What is that number? Right? When I take 10 and I raise it to that number, I get 100. 10 to the power of 10, whoa, no. 10 to the power of 10 would be 10 followed by 10 zeros, which would be, I don't know what that is, like a trillion or something? I don't know. All right, so let's think about that again. I need to raise 10 to something, which is going to end up being the same thing as 100. 10 to the power of 2, there you go. So I'm going to say, okay, let me give us some more room here. I'm going to say that instead of saying 1 over, we'll call it 1 over 10 to the power of 1 over 10 to the power of 2. Now, can we all, not just Quinn, can we all accept that 1 over 100 is the same thing as 1 over 10 squared? Can we all accept that? Not just Quinn. Brandon says yes, and Sindhuja. Okay, great, Donna. Thank you. So back to you now, Quinn. Can you tell me another way I can express 1 over 10 squared where I don't have it as a denominator? 10 to the power of what would be the same thing as 1 over 10 to the power of 2. So instead of 10 to the minus 2. Okay, so we took the original question, which was 0.01, and made it into 10 to the minus 2. Right? Those are the same, right? 10 to the minus 2 is the same thing as 0.01. That's just a fact. So now we have the two sides with the same base. So I'm going to ask you finally now, Quinn, to tell me what x is based on what we have done before. It's equal to -2. So the log base 10 wasn't said to be base 10, but we know that we can always imply a 10 when there's nothing there. The log of 0.01 is in fact -2. Thank you, Quinn. Okay. Is there anybody who needs me to go over any part of that again? I'm taking Quinn out of my list for now, and I'm spinning again before we go to our next question. Anybody needs me to, and I'm okay, I see who the next person is. We're going to come back to that in a minute. Okay, here comes my next question. The log base 3, the log base 3 of 27. That's my next question. Bring that down. And here is our question. Okay, so Alexander, it's your turn. Are you there, Alexander? Perfect. Are you able to give us an answer, or do we go through the steps? Help me out here. How do you want to do this? You want to go through all the steps, or do you think you know exactly what the answer is right now? The log base 3 of 27. Do you know what the answer is, or do we give me one? I think I can get the answer. Okay, sure. The log base 3 of 27. What is that? Is it 3, he says? Yes, it is, sir. The log base 3 of 27 is in fact 3. Now, do we need to go through the steps, or is everybody comfortable with that answer? That the log base 3 of 27 is 3. Let me just check with the room on that. We can go through the steps if we need to, but he's right. Sindhu, does a yes mean that you're okay with it, or that I need to go through the steps? I'm not sure what that meant. So you agree. Okay, we're fine. So again, really what we're saying is, what do I raise 3 to that gives me 27? The answer is 3. Okay, thank you very much, Alexander. Let's try, we have 2 more to get to. One is going to be a little bit more work. Okay, let's see who's that. Yes, Quinn. Mm-hmm. Yep. Yep. Well, we're actually going to look at some applications of logs a little later on. Generally, the thing that logs allow us to do is solve equations where the unknown is an exponent. Let me give you an example. Let's say you did the finance unit in grade 11, I'm assuming. And one of the formulas in the finance unit was actually an exponential function for compound interest. If you had to solve for the exponent in that equation, then you would really be using logs. To do it accurately, you'd be using logs. I'll give you a typical example of how a log could help you to solve an actual, everyday situation. You are sitting with your financial planner, and he says that the current interest rates are about 5%. I'm just pulling a number out of the sky, right? And you're asking him, well, at the 5% that I'm working with right now, how long will it take me to double my money? The truth is, to answer that question, because to put that into the financial equation for compound interest and solve that, you need logs to do that, because you're actually solving for an exponent, and that's why logs really were developed in the first place. All right, so logs are used for solving equations when exponents are involved. The other thing that and we're going to go through this, is they've developed log scales for various things. If you're doing chemistry, then you would have been familiar with the pH measurement system for measuring the acidity or alkalinity of substances. That's a log scale. You'll be familiar also, if you're doing physics, with the decibel scale for measuring sound intensity. That's a log scale. And we'll talk about why they use log scales for these things as well. If you are in the field of geology and you're measuring earthquake intensities, that's also measured on a log scale. And again, there are reasons for why they use log scales for those things. But yes, that was a giant leap forward. You're right. When they developed logs, it was a giant leap forward for quite a few areas of mathematics. Okay, and that's a great question, by the way. All right. Let's get back to this. So, who did I have next? I forget who I had. Who was next? Okay, so that was Alexander. Alexander just did his thing. So let's take Alexander out, and we're going to be talking about the log base 4 of 1 over 64 as our next question, and that goes to looks like Brendan. Brendan, it's your turn. Are you there, Brendan? Perfect. Okay. Are you able to answer the question right away without us going through all the steps? The log base 4 of 1 over 64. Do you think you know the answer? No? All right, so we'll go through the steps then. Let's set it equal to x first. Let's do that first. All right. And then, sorry. And then, here's a part that I'm going to be asking you for now. Put this in exponential form for me, please, Brendan. Give me the exponential form of what I just wrote down. I just set it equal to x. So there's an exponential way of saying that. What would that be? Four to the power of x equals perfect. Perfect. Now, you know that this has to do with trying to find something that has a base of 4. We know that. So that's my next question for you now, Brendan. What can I raise 4 to that will give... you're ready with the answer all of a sudden. Okay, good for you. I can raise 4 to the power of 3, right, to give me the same thing as 1 over 64. So we now know that I can rewrite that as 4 to the minus 3. So now Brendan has an answer for me, which is that x is equal to minus 3. So my original question was, what is the base for log of 1 over 64? And Brendan is now right. The answer is that the base for log of 1 over 64 is minus 3. Okay? Is everybody comfortable with that answer? Before I go any further, is everybody comfortable with that? Let me check in with the room as usual. Let's see. Sebastian, how about you? Does that make sense? Sebastian, are you okay? Good. And let's see. How about Shiobon? Shiobon, how about you? Does that answer make sense to you as well? Great. Okay. This one is not so obvious. Not so obvious. We need to get somebody who is gonna really put. Let me take Brendan out, by the way. Is gonna have to really think this one through a little bit more. The log base 8 of 4. And the wheel says that Thomas is going to help me out with this. All right, so Thomas, we're gonna slowly and methodically go through this. We're not going to sort of just leave you there on your own. We're going to work with you on this. Where did you get the negative 3 again? Okay, let's go back and look at that. And thank you very much, Edmund. I like the fact that you're stopping me and asking me the question. 64. Is there a way to express 64 with a base of 4? Because since it says 4 to the power of x, I'm trying to make things have a base of 4. Well, what do I raise 4 to that gives me 64 is the question, Edmund. That's the thing I really need to answer. What number can I raise 4 to that gives me 64? Would you agree that that's 3, Edmund? Okay. So I'm just, instead of saying 1 over 64, I'm saying 1 over this thing which represents 64, right? That is the same thing as 64, 4 to the power of 3. But instead of leaving it as a denominator, I can make it into a numerator by saying 4 to the minus 3, right, Edmund? That makes sense, doesn't it? Okay. And then, of course, because they now both have the same base of 4, that means that x is equal to 3. Okay. All right. You're welcome. Love the fact that you're asking the question. Don't want anybody sitting there not understanding and not asking. That is not acceptable. So thank you, Edmund. Okay, now, Thomas, are you there? Where's Thomas? Perfect. Okay, Thomas, we're going to walk you through this. All right, we're not just going to, this is not an obvious one. I'm just telling you that right now. It's not an obvious one. So we're going to have to give you some help with this. And I may ask for somebody else to jump in at some point, but we're going to start with you. Set that equal to x. All right, Thomas, give me the exponential form of this equation. We're looking at a log form. Give me an exponential form for the equation now. Think about how we've done that in the past and give me an exponential form. I can bring the page up a bit to help you with that. Right? Look at what other people have done to put it in exponential form. And hopefully you've been taking notes, not just Thomas, everybody's been taking notes as we go along. So exponential form now, please. That's the log form. Give me exponential form now. Not sure? Okay, let's go back and look at the last one then. In fact, let's use this one right here. So let's start off with this. Let me bring this over here actually. Right? So I'm going to first of all set this equal to x, because that's what we're trying to figure out. And then I'm about to give you what the exponential form of this is. And I'm going to ask you to tell me the exponential form of the other one is. Okay? The log base 3 of 27 is equal to x. Therefore, this base that I'm circling right now of 3 raised to this thing on the other side of x is equal to 27. Write that down, Thomas. Write down what I just did. The log base 3 of 27 is equal to x. Therefore, 3 to the x on the other side is equal to the 27. All right? Tell me when you've got that down, because I'm going to go back to the other question. Okay, so write the question down, and then write down the way that I wrote it in exponential form. And then when you've written it down, let me know. Okay, so apply the same logic, the very same logic to this. Right? It's just different numbers, but it's the same logic. And tell me what this would look like if the log base 8 of 4 was equal to x. How else could I write this in what we're calling exponential form? You're just going to switch up the numbers now. 8 to the power of x equals 4. Perfect. Okay, thank you, Thomas. Now, I don't think anybody would necessarily look at that and think, what can I raise 8 to that gives me 5? I'm not sure what that is. I can't think of any number I can raise 8 to that gives me 4. That's a little messed up. So, thank you, by the way, Thomas. But there is something that we can do. I just took Thomas out, and I'm going to see if I can help you through this now. What if, and this is going to come up in other classes when we're dealing with exponential functions. Hussein, what if, Hussein, are you there? Change both sides. Okay. Oh, look at what Brandon just said. Brandon's actually on the right track. Hussein, read what Brandon just said. Change both sides to powers with a base of 2, then set the exponents equal to each other and solve for x. He's actually right. He's actually right. So, Hussein, you have joined us. He says, I don't think anybody can think of anything you can raise 8 to that gives you 4. Can't think of it off the top of my head. But, very smart. Yeah, he's very smart. A lot of you, actually, I think are brilliant. But, he's thinking, what if we made them both have the same base of 2? So he's thinking that 8 can be 2 to the power of something, and that 4 can be 2 to the power of something else. So Hussein, let's come back to you. That 8, what can I raise 2 to that gives us 8? What are you thinking when you see that, Hussein? 2 to the power of something gives you 8. I'm going to replace this 8. I'm going to circle it in green. And I want to replace that 8 with 2 to the power of something. 2 to the power of 3. Good. So let's put that in. So this could be 2 to the power of 3. But remember, it was always raised to the power of x. So that's still there. That x is not gone. I'm just replacing the 8 with 2 to the power of 3. This 2, though, you're absolutely right, is being raised to the power of 2. Okay, so the one thing you're missing from yours, Hussein, is that there still was an x there that should still be there. Okay? Now, let's see if we can think this through some more. Remember the power law of exponents? If I raise one exponent, which in this case is 3, to another exponent of x, how can I combine those two exponents? I'm going to stick with you for that one last part, and then we're going to go to somebody else. Do you remember that power law of exponents? 2 to the, in fact, let me come over here and show you what I mean. If I had 3 to the power of 4 to the power of 5, what's another way of saying exactly the same thing? Right? 3 to the power of 4 to the power of 5 would be the same thing as 3 to the power of 20. Absolutely. So what you're doing is you're multiplying the two exponents together. So instead of saying 2 to the power of 3 to the power of x, oh, you're saying 2 to the power of 3 times x. You're absolutely right. And that's still equal to 2. Okay. Thank you very much, Hussein. Let me give you a break. All right. So we gave who was it before? I think it was Thomas. Gave Thomas a break. We're going to give you a break. We're going to get another person to tap in now. All right. So Hunayn, are you there? Quinn, 2 to the power 2. Yeah. Oh, sorry. Yes. Thank you. Quinn. Yeah. What happened to the 2? Yeah, the 2 kind of got lost into the ether there. You're quite right. You called me on that, and you're quite right. So 2 to the power 2. So, who did I just say? Hunayn, where are you? Where are you, Hunayn? You're there, right? Where is Hunayn? Hunayn is supposed to be in class. Let's just make sure that I'm not calling somebody who's not here. Yeah, Hunayn is supposed to be here. Hunayn, where are you? Folks, I've always said that this is certainly not acceptable. If you are supposed to be in class, you're supposed to be attentive, and anytime I call on you, you're supposed to be able to jump right in there. Okay, good. All right. So, I hope you've been following along what we've been doing. The last thing that Hussein did is he turned that 8 into 2 to the power of 3. Then he said, okay, let's take that 4, make it into 2 to the power of 2. And then he combined the two things together. He said 2 to the power of 3 to the power of x means 2 to the power of 3x. All right? So far, so good, Hunayn? Does that make sense? Okay, good. Now, what we did on previous occasions, we said, okay, these two things are equal. The 2's are equal. It's an equation, which means that the two sides must be equal to each other, right? What does that suggest that we can now state as a new equation? Give me another equation that's implied by what's on the screen right now. What other equation can we infer from what's on the screen right now? You're over to you, Hunayn. If this is an equation and it says that the base to the power of 3x and the base to the power of 2, where the two bases are the same, right? 2's on the two sides. Give me another equation that would result from that, is what I'm asking you for. Can you suggest something which would be a logical conclusion from what you're seeing on the screen right now? If you need a hint, you need to ask for it. Quite happy to help you out if you need it. Sure you can. Just have to ask. Let's go back and look at the one that we had. Let's see now. Let's go back to maybe. Oh, sorry. Come on. Okay, let's look at this one right here. All right? Can you see what we're looking at, Hunayan? Okay, let's see. Somebody has their hand up. Hunayan has raised his hand. Yes, go ahead. Yeah. Go ahead, Hunayan. You say, oh, you're saying you can see it? What I'm pointing to this line that has the red box on the two sides and the green boxes as well. You say you can see that, right? Okay, perfect. So notice what we said. When the two sides had the same thing in those two red boxes, which they do, the two on the left is the same as the two on the right, that whatever was the exponent on the left must be equal to the exponent on the right. Those green boxes have to be equal as well, right? So if the two red boxes are the same, remember, this is an equation. An equation means that the left is equal to the right, exactly equal. So if the red boxes are the same and the green boxes have to be the same, so we can just simply say that x must be equal to minus 3. That's the equation that we're going to, that's implied from the previous line. I can just make the exponents equal to each other. So far, so good? Hunayan, does that logic make sense to you? Perfect. Let's go back to where we were. No, the green boxes are the same. So what does that suggest to you as an equation that I can write down right now? If these two sides are equal to each other, give me another equation that would be suggested from what you're looking at. Follow the same logic as what we just had on the board a while ago. Does that make sense? Or do you want us to go back and look at what we had again before? We can do that if you need to. Would it be? Of course it is. Of course it is. 3x is equal to 2. And this is just a simple grade 9 equation at this point. In fact, I won't ask anybody else to solve it. That would mean x equals 2 over 3. Right? So to answer the question before, I don't know why it's doing this right now, that the log base 8 of 4, I'm going to write the question down again. The question was the log base 8 of 4. The answer is 2 over 3. Now, how can I justify that answer? How does that answer make any sense? Well, I'm going to write down what this implies as an exponential form. This is saying, what this is implying is that 8 raised to the power of 2 over 3 is equal to 4. Right? That's what it's implying. And if I raise 8 to the power of 2 over 3, I'm supposed to get 4. Well, what does 8 to the power of 2 over 3 mean? Take yourself back to, I want to say this is probably grade 10 at this point. Does anybody remember what an exponent of 2 over 3 actually means? So the answer to the question is this. Let me just check it off. This is the answer. The log base 8 of 4 is 2 over 3. Let me just make sure we're clear on that. But I'm asking you now, that's the answer. 2 over 3 is the answer. I'm asking you now, does that mean that 8 to the power of 2 over 3 equals 4? And I'm saying yes. How do we justify that? What does the 2/3 mean as an exponent? Does anybody remember what that means? What does 8 to the power of 2 over 3 actually mean? Right? What is an exponent? You're supposed to have done rational exponents, I want to say in grade 10, might have been grade 11, I don't remember. What does that mean if I'm raising something to the power of 2/3? Does anybody remember what that actually means? No? I'll tell you, because it doesn't look as if anybody remembers it. It means the cube root of 8 raised to the power of 2 is what it means. So the number at the bottom is a root. In this case, the third root. So it's the third root of 8 that you raise to the power of 2, right? Or the cube root, same thing. Leanne, looks like you're about to ask a question. Or you change your mind. Are you good? Leanne, you had a... Okay, Quinn, go ahead, please. I sure can. I sure can. Yeah. Yeah. Whenever you have, and this is good for us too as an exercise because we're dealing with an exponential function. So it's good that we understand what an exponent, which is a rational exponent, means. Let me go to a different page. All right. Let me take something like 16 to the power of a half. 16 to the power of a half. Does anybody remember what that means? 16 to the power of a half? What it actually means? No? Nobody remembers what that actually means? It means the square root of 16. Why am I saying the square root? Thank you, Donna, and thank you, Robo. It's the square because the number at the denominator here is 2, so it's the second root. And of course, I don't have to put a 2 here because when you don't have anything there, it's implied to be a square root. So it's the square root of 16, then raised to the power of 1, because you take the root, which is a denominator, to the power of the top, which in this case is 1. Now, raising anything to the power of 1 doesn't change anything. So this is really just simply equal to 4. That's really all it is, right? So if I now took 8 and raise that to the power of 1 over 3, what I'm now saying is, what is the third root of 8? Again, raised to the power of 1, right? Why am I taking the cube root? Because the denominator of this exponent is 3. So it's the third root. The third root of, and then after I find that root, I raise it to the power of 1. So in that case, it works out to be 2. But in our case now, let me come back to the question that I was asked by Quinn. What we're doing is we're taking 8 to the power of 2/3 this time. So it involves two things. It involves the cube root of 8 raised to the power of the top number, which is 2. The cube root of 8 is 2, and then 2 to the power of 2 is in fact 4. Do you see what I'm going? Do you see where I'm going with that now, Quinn? That's why we got that 8 to the power of 2/3 is equal to 4, right? Does that kind of sort of make sense? Because I can do that again if we need to, right? The top number is what you're raising it to. The bottom number is the root of that number. Okay? Quinn, does that make sense now? Yeah, okay. No. It turns out that we could do it either way, right? Because we could have said this same question here, 8 to the power of 2 over 3. You could do this instead. Take 8, square it first, and take that answer and find the cube root. It turns out that the order in which you do it doesn't matter. So I can raise it to the power of 2 first and then find the cube root. So in that case, what I would have is the cube root of 64, because 8 squared is 64, and that answer is still 4. So the top number, you're going to raise it to that number, which you can do first. The bottom number is the root that you're trying to find. Okay, yes, Quinn, please go ahead. Correct. I wouldn't think that after a while you would need to go through all of these steps anymore. I just wanted you to accept that if you had to find, to come back down to the question itself, if you had to find the log base 8 of 4, the answer is 2/3 because raising 8 to the power of 2/3 does in fact work out to be 4. Right? The question was, what is the base 8 log of, what was the question again? Yeah, the base 8 log of 4. So 8 to the power of 2/3. That's why the answer to the question is 2/3, right? Because 2/3 is, remember, when you're asked to find a log, you're asked to find an exponent. So what exponent on 8 gives you 4, right? What can I raise 8 to which gives you 4? And the answer to that question is what's in this green box, which is the 2/3. Log base 8 of 4 is 2/3. Finding some inverse functions, right? Finding some inverse functions. So I'm going to start off with a log function and then take that log function and make it into an exponential function. Then I'm going to take an exponential function and make it into a log function. If we were to graph both of these on the same axes, then one should actually be a reflection of the other across that y equals x line. So what I'll do is, after I finish getting the inverses, we'll test it out by putting it in a graph and showing that that graph is a reflection of the original function across the y equals x line. So we'll try that. Okay, so here we go. Inverse functions, remember, are when you take the x and the y and you flip them, right? And in the case of a log function, it's going to become an exponential function, right? Okay, so here we go. Here we go. Oh, I have another one down here. Actually, let's do this one first. Put this one out of the way here. Let's do this one first. Put that on the side there. So we're focusing on this, the base 2 one. What would you suggest would be the first step in finding this inverse function? Remember, at the end of it, we expect to be an exponential function because inverse of a log is an exponential function. Inverse of an exponential function is a log function. So what do you think would be a good first step for us to take in trying to find the inverse of this function? I'm just throwing it out to the whole room now. I'm not just asking anybody in particular. Switch your x and the y. Thank you, Hussein. So we'll do that. So x equals 3 log base 2 of y minus 4 minus 9. Okay, that's a good start. Can anybody suggest what might come next? So we switch the x and the y. So of course, we have to isolate the y now, right? Does anybody have an idea of where next? Plus the 9 on the two sides. So far, that's just simple regular algebra. So we have x plus 9 is equal to 3 log base 2 of y minus 4. Okay, that's good. Anybody can suggest another step? Remember, we're trying to get to that y. We're trying to isolate that y. So what would be a good next step in finding that inverse function? Divide by 3, absolutely. So x plus 9 divided by 3 is equal to the log base 2 of y minus 4. Okay, so far, thank you, Quinn, thank you, Brannon, thank you, Roma. So far, and Sinduja, thank you, sorry. So far, all we've really done is some regular algebra. But now we're at the point where we have to see if we can get that log out of the way. Do we have a solution for that? Is there any suggestion that we can use to do that? The log base 2 of y minus 4 is equal to this thing on the other side, x plus 9 over 3. So Roma says 2 to the power of. There you go. What you're doing, Roma, and if you look at what Roma says there, is she's really putting it in exponential form. And we've been doing that all along. Put it in exponential form. So what was the base? The base is 2. So 2 to the power of all of this, which I put it in a bracket, x plus 9 over 3 is equal to the y minus 4. To get rid of the log, we just put it in exponential form using that particular base. So 2 to the power of the x plus 9, and I need to tidy this up a little bit. Let me try that again. X plus 9 over 3 is equal to the y minus 4. Let me just check in with everybody and make sure that that makes sense. Did Roma's step make sense to everybody? Right? I need to know. Donna, okay, great. Fantastic. So obviously we have one last step to finish this up. And that's just to simply, let me get this out of the way, is just simply add the 4 to the two sides. So now here comes our final function, that y is equal to 2 to the power of x plus 9 over 3, that's an exponent, plus 4. If we have time at the end, I'm going to try to put this on a Desmos graph and show you that 1 is a reflection across the y equals x line. Okay, there's your inverse function. That function is the exponential form of the original log function that we had as a base 2. Okay? All right. Let's try this the other way, which is, let's take this and make it into a log function. That's an exponential function. The exponent is the exponent. The exponent is the variable. So let's go through those steps again. Step 1, anybody? What's step 1? This is going to be very similar to what we did before. What's step 1? What would be step 1? Come on, folks, get involved here. Everybody should be jumping in and giving me an answer for that. What's step 1? I'm trying to find my inverse function, plus 6. Well, we do this first. Let's just switch the x with the y first. That's generally kind of a good place to start. So x equals 3, 7 to the power of y plus 1 minus 6. That's, I mean, you can always do that at the end, to be honest. There's no rule that says it has to be done at the very beginning, but at some point we have to switch x and y. So why not start at the very beginning? So yes, let's add the 6. So x plus 6 is equal to the 3 times 7 to the power of y plus 1. Divide by 3. You guys are ahead of me, Sinduja, Hussein, and Roma. Well done. Divide both sides by 3. So x plus 6 divided by 3 is equal to 7 to the power of y plus 1. Okay. Now we're stuck. Everything we did before is basic algebra. Add the 6, divide by the 3. But how do we get that 1, that y now? That's the big issue here. Let's see who is going to give me an idea of how that might work. How can we get that y on its own? Got to get that thing, which is an exponent, to not be an exponent anymore. Use the logs. Okay, Don. So give me a log format then. You're right. Remember, that the inverse of an exponential function is a log function. So what would be the log form of what we're looking at right now is the question. So Roma says the log, and by putting it in a bracket, I think you mean base 7. That's probably what you mean. Of the x plus 6 divided by 3 is equal to the y plus 1. You're absolutely right. So we're going to take a log base 7. Look at it as the subscript of the x plus 6 over 3 is equal to the y plus 1. Absolutely correct. Absolutely correct. And you're being thanked, by the way, by Donna for that. Roma. So we minus the 1 from the two sides. Good. So y, finally now, is equal to the log base 7 of x plus 6 over 3 minus 1. Minus 1.